Hey everyone, Michael Unger here with another edition of Ask an Astronomer. And as always, we have our astronomer, Marley, just a few doors down from me on this lovely day here in the unceded territory of the Musqueam, Squamish, and Tsleil-Waututh. Hey Marley, what's happening?
Not much. End of the day. End of the day.
Well, end of the day for you, I will still be here because we have an event tonight. We've got our drag night. It's always kind of weird here in Vancouver. Pride is generally celebrated in June. But we like to do some things differently in Vancouver. So Pride is actually at the end of the month, and of course we're celebrating in the middle of the month. But whatever, Pride is whatever you want it to be. So we have themed this episode Pride and JWST, and we thought it would be a nice segue to kind of talk about a few things, and especially because JWST has an anniversary. There's a whole bunch of cool images that we can get into. So if you're out there watching on YouTube land or on Facebook and have any questions about any of the things that we're going to talk about or anything under the universe, drop your question into the comment section and we will answer them all before we get to the half-hour mark. So Proud and Pride, we're talking about the universe and everything it encompasses, including us. We're very passionate about all of this stuff. But let's start talking about JWST. It's about almost a year. I actually got a notification in my memories from the event that we did, or I guess like NASA did, when we were in our theater, we got live streamed across the world. So it's been a year. So what has that wonderful telescope been up to?
It's been up to, a lot. Yeah, yesterday actually was the 1 year anniversary of when we got the very first images from JWST, which was a big deal, quite large. The actual very first image came the day before, I think it was, when they showed the cluster, the SMACS cluster, unveiled it at the White House with the president and the vice president and Bill Nelson. And it was really annoying because they kept the picture very small and every astronomer was like, could you just full screen that please, and thank you. Yeah, it was actually very frustrating for everybody, but nonetheless we got the full image eventually. And then in addition, we got all of these different images. These are the five main ones. Of course, we've got the one contributed by the Canadian Space Agency. I think that was when the stream dropped out last year.
Yeah.
And that is the spectrum, right? The spectrum from the exoplanet, right? That was very exciting. The WASP 96b exoplanet, along with the Carina Nebula and this Southern Ring Nebula and Stephan's Quintet, right? So these are like our first five images that kind of really showcase the capabilities of the telescope. And they're the first scientific images as well. We had been getting engineering images up until that point, but these were like the big ones. There was a lot of what are they going to show us? It was a really fun time a year ago, looking back. And so for the anniversary, they released, the anniversary image, which they do a lot of. You were going to say something, Michael, and I cut you off.
No, I was just going to say it was really a really fun day, and our friend Natalie Willette got dropped out of there. But I was going to say, which one of these is your favorite? Let's go through all of them, and I'd love to hear what your favorite one is.
Oh, well, I don't know. I'm a galaxies lady, so it's one of these two. So it's either the cluster, or it's the either the SMACS deep field, like Webb's first deep field, or it's the Stephan's Quintet. I like the Carina Nebula because it's very pretty. It's just very nice to look at. But in terms of, I guess, like science, I really like the SMACS cluster. There was just so much going on in that image. Though the general consensus among my family is that it's the Carina Nebula is the best one. Visually appealing, I guess. What's your favorite?
Well, I actually probably go with the exoplanet data, because I think that's like the one that has the actual science. And of course, I'm biased because Natalie was on that team as well. And we'd like to give her props because she's been working hard, and especially because there's Canadian contribution on that one as well. So that was pretty cool. So I'll throw the question out to all of you on YouTube land and Facebook. Which one of the original JWST images is your favorite? So let's go into some of these images, maybe some new ones.
Yeah, I do want to note that you said it was your favorite because there's a graph, and that's science to you. So I don't want to hear it when I put graphs on things anymore because they're science and it looks good. Okay, this was the anniversary image that they released yesterday. It is the I don't remember how to pronounce this, Ophiuchi Cloud Complex, it's the closest star forming region to Earth at 390 light years away. And in this image, there are no foreground stars in this image. So even the stars with the diffraction spikes that you're seeing, which is what happens is the artifact of how the telescope is built. Even those are part of this cluster, right? Part of this cloud complex. They're not in the foreground as they typically are when we look at, say, large galaxy images and stuff like that. These are all in the same location, more or less. When we look at it, it usually looks quiet, but JWST really highlights some very, like a lot of chaos happening within the cluster. You have these large red clouds. These are molecular hydrogen clouds, and you have stars with jets coming off of them that are causing these large clouds, right? Kind of like when they first are born, they push out a lot of energy in jets, and that pushes this gas and dust away, or in this case, molecular hydrogen. And it makes these long, interesting features. There's one up in the top right-hand corner. You can kind of see two little jets coming off of it. One here has caused other billowing structures. So you have a lot of activity in this very, very beautiful image. There are 50 young stars in the image, and this one here in the center has kind of blown out its own little bubble in this region for whatever reason. And there's two up here that are kind of indicative. The little shadows coming off of them kind of show these circumstellar disks. So the beginnings of planetary systems starting to form in these young stars. And it's just a very dramatic, beautiful image, given to us by this telescope for the 1 year anniversary, which is, I think, a good 1 year anniversary picture at any rate.
Absolutely. Yeah, there's a lot going on in that image, and it is very different than your classic, I think, nebula type photo, because there's just like, it's not very symmetrical. I think that's what makes it kind of interesting to the eye.
Yeah, right. There's not, like, you look at the Carina Nebula, right? It's very like segmented. You have the orange, you have the blue, right? The way the colors come down and the way where everything is. Whereas in this one, there's just a lot of motion and a lot of activity, which you don't really, it's a still image, but you can see all of the movement quite clearly in this one, as opposed to some other nebula images that you might be more familiar with. Typically, those are like supernova remnants, right? So it's all radiating out from one spot. Those are the really popular nebula images, or can be. Whereas this one just has a very chaotic, but also almost a stillness to it. It's just a very, very interesting image to look at.
Yeah. And then, of course, we were always talking about these deep sky objects. That was really what JWST was going to focus on. But JWST also turned its cameras towards our solar system as well, right?
Oh, yeah. It's been doing that, for which I'm not surprised it did, but it's just interesting how much it's been able to see when it looks towards our own solar system, right? It doesn't really look at anything, inside of the solar system, right? It's not looking at us. Like, that would be really bad for all of its instrumentation. It's looking out, right? So we get Jupiter, we get Saturn, Uranus, Neptune, like we get those outer planets, which is great. So this is a recent one of Saturn, which I was really excited to see. Saturn's my favorite planet. And they had also taken a specific look. I saw on their outline for what their programming schedule, they were looking specifically at Enceladus, and that they did a bit earlier, and they did find the huge plume coming from the southern pole of Enceladus, a plume of like water ice that feeds one of Saturn's rings, right, which we knew from Cassini, but then Webb took a look at it and showed just how much of the particles were like coming out. It's like enough to fill an Olympic swimming pool every couple segments of time, like very quickly. There's a lot of material coming out. And when it looked at Saturn, we get this interesting look at just not only the disk of Saturn, like the physical part of it, but also the rings, right? It's very dark because of the methane gas that makes up Saturn, absorbs almost all of the light. So the disk is what that's called, looks very, very bright, or dim, even though it's not a disk. It looks like the main body, I guess, of the planet. The icy ring is very, very bright. And so we get to see really easily the segments between the rings, and even the division and the gaps between them, which is always very exciting, and even some of the moons, right? So it's just a new look at something in our solar system that we're able to see and to study.
Very, very cool. And of course, let's move back to the classic deep universe pictures to round out.
Oh, yeah. So this is a Wolf-Rayet star, which was, I don't know, I really like this one because the purple, I think, more than anything. We had the Tarantula Nebula, which I thought was going to be one of the first images, actually. I was thinking they would do something like this, star forming region, very dramatic, very beautiful. And now this is one, I know, thank you for skipping to this one, Michael, because I love the galaxies. This is from the Cosmic Evolution Early Release Science. There's multiple images make up this one. So they've taken different images of the sky and kind of stitched them together into one image. The stars with the spikes are now the foreground stars, right? So they're not part of the what we're focusing on in the background. But across all the different images, there's about 10,000 galaxies in this view, even though you can't possibly count them all. There are about 10,000 each in this view. Each little square, each little segment had under an hour of exposure time. So that means that the telescope only collected light for under an hour. And in astronomy and with telescopes, the more light you collect, the more you're able to see. And so to see this amount in under an hour is just very amazing, and really speaks to how well built the telescope is and how well it's working. The galaxies that are scientifically interesting are the ones that you can't really see, right? They're the little tiniest reddest dots, kind of in this area in particular. There's one that is now currently the most distant active supermassive black hole in this survey.
Whoa.
Yeah, so this was very exciting. It existed 570 million years after the Big Bang. So in this galaxy, we're looking at it as it was 13.2 billion years ago. So we're looking very far back. It's very young. And the black hole itself only weighs about 9 million solar masses. For context, the black hole at the center of our galaxy weighs about 4.6 million times the mass of the sun. And very, very distant ones in other galaxies that we've known about for decades are more than 1 billion times the mass of the sun. So it's very young, but it, has more mass than our galaxy's black hole does currently, right? And they found that it's also very hungry is the word they use to describe it, which means it's just consuming gas and dust and stars in its accretion disk the fastest it can, according to theory, right? So when we do the theoretically, it could go this fast. It's doing it that fast, right? It's consuming all of it that fast. And that's what they saw when looking at the spectra and other spectral features, which is kind of what the graph below is showing. It's showing the broad range of the accretion disk, or the broad model is the gas in the accretion disk. So that's that yellow line is showing, where it peaks. They're looking at hydrogen specifically. It's a spectral feature that's easy to find and easy to use, and other science reasons. And then the purple line is showing the slower gas in the galaxy. That's coming from stars that are actively forming. So the spectral features that can come from multiple places. So they make a model for gas in the accretion disk, and they make a model for the stars in the galaxy. There's one that's not shown. The oxygen spectral features show that the stars in the galaxy surrounding this black hole have typical speeds for what would be a very massive galaxy. So it's very interesting because detecting these kind of smaller and very young supermassive black holes during early times in the universe will become more common with JWST, and it'll also help us understand how these types of structures form and change over time, right? Which we don't fully know yet.
Yeah, this is amazing. So almost as advertised, JWST has delivered, as we've seen this first year, and there's only going to get more. We're going to get better pictures, more data, and giving us this view of the universe that we've never had before, right? Which brings us to the telescope itself. JWST, we call it JWST. We have these conversations a lot here at the Space Center. And of course, being Pride Month, we thought this would be a great chance to talk about what that all means. And it does get very complicated. It gets a little political as well, but these are important things to talk about, especially especially for us as communicators. We are talking to the public, and quite often we get questions about these things. We use the term JWST as an acronym. We're obviously more concerned with the telescope and the data that comes from, but it was named after someone that we should probably talk about, and we can kind of give some context for anyone out there that doesn't know the story.
Yeah, this was a big, I would still think it is a big deal, but it really was a big part of public discussion in 2021 and 2022, shortly before and after the telescope launched. And so JWST is named for the James E. Webb, who was an Undersecretary of State from 1949 till 1952, and he was the administrator of NASA from February 14th, 1961 until October 7th, 1968. He was actually the second ever administrator of NASA. And during his tenure, he oversaw a lot of the Apollo program, right? So he was there during the Apollo 1 fire with the deaths of the 3 astronauts, right? And so in the ensuing investigation, he had a very active role in, kind of maintaining NASA's image and explaining to the public what had happened, and ended up taking a lot of responsibility for the deaths of those astronauts and kind of keeping NASA as an agency out of it. ended up supervising the launch of over 75 space science missions, which is very impressive. And at the same time that he was overseeing this during his tenure as administrator of NASA, he was also the administrator during what is called the Lavender Scare, which was a period of time in history where people were fired for their sexual orientation, right? So for being gay, gay men and lesbians were targeted very heavily for this. And we know for sure that there was at least one NASA employee that was fired while James Webb was administrator. In 1963, his name is Clifford J. Norton. He was a NASA budget analyst, and he was fired for his sexual orientation. I don't want to say the reasoning behind the Lavender Scare was very close. You're probably more familiar with the Red Scare, which was tied to communism, right? So, this idea that we have to purge the government of these undesirable people. And the idea was that gay people or LGBTQ people were a particular security risk because they were easier for blackmail, but also they were also of poor and weak moral character. Right. And it wasn't like a new thing, right? It started, the official kind of start you can maybe tie back to, it was in 1953 under President Dwight D. Eisenhower, an executive order, right? It became policy, and it became like federal governmental policy to investigate, interrogate, and remove gay men and lesbians from federal government. And so it became a very widespread just thing that happened, right? It was a policy that was followed. And it's not to say that it ended like that. It's still not, I guess technically, in 1995, Bill Clinton signed an executive order banning discrimination based on sexual orientation for granting security clearances. And in 1998, the discrimination was banned in government employment, that type of discrimination. But it is in no ways over, though. I want to emphasize that there's still lots more that can be done and should be done in terms of protecting people's rights in the workplace, especially concerning sexual orientation and gender identity.
Yeah, and a lot of that is still coming up in politics now. Even those policies that Bill Clinton maybe had good intentions of, created this "don't ask, don't tell" type of policy, which again wasn't very good, and looking back is not very healthy for anyone that may be in service and is still going through a really hard time.
Yeah, no, it's by no means fixed. It's just James Webb was overseeing NASA during this specific moment, and it was very much very widespread and very active during specifically the Cold War, which is why these dates kind of intercede. NASA did, so this was the big problem. Naming it after James Webb became a very big point of contention as to why are we naming a telescope after someone who oversaw this type of policy, right? When traditionally, if you think of telescope names, they're names after scientists, right? Like Edwin Hubble, the Chandra X-ray telescope, they're named after scientists or people who have made a scientific contribution. The reason James E. Webb was picked was because he was overseeing the Apollo program and was kind of laid the groundwork to a lot of missions that end up coming up after his time, right? Was the NASA justification for the name. Because of pushback from the astronomical community and calls for renaming the telescope, NASA ended up doing an entire historical report, right? So they looked into James E. Webb, his time as the Undersecretary of State, where this policy would have also been heavily applied, and during his time as administrator of NASA. And the NASA historical report says that there was, quote, no available evidence directly links Webb to any actions or follow-up related to the firing of individuals for their sexual orientation. So he was never, I guess, directly involved. But they do also say that the firing of people due to sexual orientation was accepted policy at the time. Right. And basically the job of a NASA administrator is a policy-based job, right? You were told this is what NASA wants to accomplish. You do the policies that make that happen. You look at the policies to make sure that happens. So this is kind of where we stand. NASA did do this investigation, and they decided they were not going to rename the telescope because they couldn't have officially find, that he said the words, "I'm firing you because you were gay," or anything like that. There was no direct linking of it. They have maintained they're going to keep the name of the telescope. And there's members of the astronomical community who very much disagree with this, finding it very hypocritical to insist on giving this James Webb credit for the exciting things that happened during his leadership, like the Apollo program, like all these missions, but somehow excusing him from or refusing to accept or acknowledge the culpability for the bad things that happened underneath his reign, which is kind of you can't necessarily have it both ways. And it does seem like NASA would really like that.
Yeah.
And so the reason a lot of you might find astronomers who refer to it as JWST, or if you're even reading it in publications written as JWST, even academic publications, is because not all academic and publications require you to use the full name of the telescope anymore because of the background surrounding the man who it is named after. So this is a press release from the American Astronomical Society, where they say that it is the current policy of the journals that the acronym JWST does not need to be spelled out upon its first use in scientific papers. The Royal Astronomical Society had something similar for their publication-based stuff, but they reversed it after the historical report came out from NASA. So not all publicating bodies will have the same rules, but some still keep it in place. I couldn't find anything from AAS saying that they had reversed their decision at all. So as far as I can find, it's still their policy that you don't need to spell out the acronym. You can just use JWST.
Yeah. Yeah, and of course, here at the Space Center, we didn't really make a policy, but of course, we do talk about it. It is complicated because a lot of people that come through will have never even heard of this space telescope before. So when we use acronyms, we generally, avoid acronyms at all costs, especially one that doesn't make a nice word, like NASA makes a nice word, right?
Yeah.
Like JWST, doesn't
It's
really
not a word.
sound like anything. So it's complicated because we want to talk about the science. We don't need to talk about the weird politics around it, but we certainly don't want to give someone that doesn't deserve to have recognition. So it is a bit complicated, but it is good to talk about. I'm glad that we're taking this opportunity to talk about it here on Ask an Astronomer. Were there any other things that you wanted to mention, as we are in Pride Month?
Oh, well, I did. Yeah. What's interesting is that prior to the controversy surrounding the name of the telescope, NASA didn't really have a clear-cut policy on how to name things, how to name their missions, right? It was kind of a top-down sort of thing. Someone would just decide. Like the reason JWC got its name is because the NASA administrator in 2002, Sean O'Keefe, I think his name was like, hey, let's rename it to James Webb, right? So there wasn't a full thing. And now NASA has actually come out and in effect, as of December 20th, 2022, put out a naming policy, right? So how to name telescopes and how to name missions. And I highlighted some parts of it, specifically in the second part where it says where possible, limit the practice of naming projects, missions, instruments after individuals, which really should probably have just been what we were doing the whole time, right? We shouldn't have named it after people at all. If they are to use the name of an individual's name, though, they require that a Office of Communication historian should be a member of any naming team, and the historical analysis led by the Office of Communication will include a human capital review to ensure diversity, unity, inclusion, and inspiration are considered. So they will, in essence, perform a historical audit on the person and make sure that, nothing harmful has come from their time as people. But to kind of wrap this all up, and after explaining the history of Webb, I wanted to highlight queer LGBTQ scientists who are out doing work. And this is from Out to Innovate, which is a scientific, technical, education, engineering, math professionals group and students who advocate for equal employment opportunity, professional networking, role modeling, science education, and empower LGBTQ plus individuals in STEM by providing education, advocacy, professional development, networking, and peer support. And these are their LGBTQ Scientist, Engineer, and Educator of the Year. They award these awards every year. The scientist, I think, from last year is actually a woman who worked on JWST, one of the instruments. This year, we have Dr. Victoria Orphan as the Scientist of the Year, Dr. E. David Jansing as the Engineer, and Dr. Ramon Bartholomew as the Educator of the Year. So you can go to the website down at the bottom. They have their recognition little section, and you can go and look up all of these excellent scientists, engineers, and educators who are from a range. They're not all physicists or anything like that. Victoria is studies or is the head or the professor of environmental science and geobiology in environmental science and engineering department at Caltech, right? So very different ranges of fields, but all scientists. And there's also the 500 Queer Scientists, which is a visibility campaign for LGBTQ people and their allies working in STEM and STEM supporting jobs. You can go to the website and you can actually filter based on location. And it's all self-reported. So these are people who, have self-submitted bios and stories intended to boost, recognition and awareness of LGBTQ plus scientists and their allies, right? So you can actually find one close to your area and stuff like that, and kind of know, they're out there and not, not hidden away.
Amazing. Well, as we wrap up this episode, we actually do have a JWST question, which maybe we should name it Jack's telescope, because
Yes.
Jackie loves this telescope, right? Shout out Jack and Joan, and Sharon may be watching. Our question about JWST, you had mentioned, Marley, that it does not point back towards Earth, but if it did, what level of detail could it resolve on the surface?
I've honestly never thought about that, because the whole point of it facing away from Earth is to keep the sun behind it and to keep the heat from Earth behind it. So I think if it were to turn around to look at Earth, the instruments it'd just become oversaturated. Like, it'd be too much light. It'd be a problem. And then Miri wouldn't be cold anymore, and that'd be really bad. I haven't really thought about it, but I'm sure it'd be good detail if it were a visible telescope. Yeah. It's the same sensitivities. It'd be very good detail, but because it's infrared, I've never really thought about what would happen if it turned to look at Earth, aside from, that'd probably break it.
Awesome. Well, JJ has jumped in with another totally random question. I love this. Have you read any Neil Stephenson, Marley?
I don't
Sci-fi
think
writer?
so. I don't recognize. Sorry?
Sci-fi writer.
Have not. I don't recognize the name. No.
Okay.
Yeah.
Well, in the Neil Stephenson novel, Seven Neves. I'm not sure if I'm pronouncing that right, but on page 1, the moon explodes.
Good.
Would that be bad?
It wouldn't be great. Good. I don't know. I've been reading a lot about the moon recently, and I'm a little tired of reading about it. But no, I mean, it wouldn't be great for sure. I would be worried about the significance of the explosion, how big it is, and how big the debris pieces that would be headed towards Earth would be. I would be a little worried about that because it's a little too close to us for us to perform any sort of fancy dart maneuver and knock the debris out of the way. So I would be a little concerned. The moon also does help stabilize Earth's wobble. So Earth does wobble just a little bit on its axis. So the moon helps kind of hold it in place. So I would be worried that without the moon, we'd start to oscillate a little bit more, which would make our seasons pretty weird. So it wouldn't be good.
Yeah, and the reason Marley is a little tired of the moon right now is because we were developing a whole bunch of new moon content for the fall and the new year around Artemis. And, one of the workshops that we do here at the Space Center is focused on the moon. And we actually have this rhetorical question that we throw out to the kids to think about, which is, what would happen to the Earth if there was no moon? And one of the best answers that I ever heard was this 9-year-old kid that said, well, Neil Armstrong would just be a regular dude.
I love children. That's so funny. And you're 100% correct. He'd just be some guy.
Yeah, it's just some guy.
Yeah.
So there you go. Thank you, Marley. Some amazing research. And thank you all for watching this episode of Ask an Astronomer. Like we mentioned off the top, we've got an amazing event, and there is still some tickets. So if you're in the Lower Mainland and want to see an amazing planetarium drag show, we put together a really cool one for tonight. That's going to, the doors, I think, are like 6:37. Show start exactly at 7:30 p.m. So come on down. Rocket and roll drag night. It's going to be really, really fun. And we hope to see you back here on YouTube and Facebook in about 2 weeks. That is going to be July the 24th, 4 p.m. Pacific time. Have a wonderful Pride, everyone.